Welcome to this explainer. Look, today we're going to do something really important. We are going to completely strip away the hype, block out the noise, and ignore the science fiction to give you a highly realistic, calibrated understanding of artificial intelligence as it actually stands today. Because if you're a non-technical professional trying to navigate this massive technological shift, getting this right, I mean really right, is the difference between using AI brilliantly and being dangerously misled by it. We're going to look closely at what these systems genuinely can do, where they structurally fall apart, and we'll answer the absolute biggest question of all. Do these machines actually think? So, here is our roadmap for today. First, what exactly is generative AI? Second, the quest for AGI. Third, capabilities versus limitations. And finally, number 4, why AI cannot think. All right, let's kick things off with section 1. What is generative AI? From narrow tasks to boundless creation.
To really understand where we are right now, we kind of have to see where we've been. Think back to the 1950s through the 80s. We basically had rule-based systems. These were just rigid programs that followed explicit human-coded instructions step by step. Then the 90s and 2000s roll around and we get statistical machine learning, finding basic patterns in data, kind of like those early email spam filters we all remember. The 2010s brought us deep learning, which was huge for mastering things like image recognition and helping self-driving cars perceive the world. But it still struggled heavily with language. And well, that brings us to the 2020s, the era of large language models, systems that have absolutely mastered human language to a remarkable degree.
And boom, here is our "you are here" moment. Generative AI is a total paradigm shift. Think about it. For decades, AI was primarily analytical, right? You gave it an input, and it gave you a classification. It basically just answered questions like, is this email spam, or is this image a cat? It judged things that already existed. Generative AI, however, creates something entirely new. It writes text, it composes images, it generates code that literally didn't exist a second before you ask for it. And it can do this because it's drawn upon vast statistical patterns from pretty much the full recorded output of human civilization. Notice the stark contrast here. Historically, we've lived almost entirely in the era of narrow AI, meaning a chess program is incredibly good at chess, but if you ask it to recommend a good pizza place, it's completely useless. It only processes the world through a single, strictly defined lens. Generative AI is fundamentally different because of its massive breadth. Because human knowledge is so deeply encoded in language, a system trained on language can just switch between domains effortlessly. It can literally write a sonnet, then debug your computer code, and then explain quantum entanglement, all in sequence, without even a moment's hesitation. Okay, moving right along to section 2, the quest for AGI, defining the ultimate target. Now, the absolute most critical thing to grasp here is that AGI is not a current reality. It's a theoretical target, but it represents a monumental leap in capability. Look, a large language model today is essentially engaging in extraordinary pattern completion across a vast statistical model. But AGI? AGI would mean a machine could reason about genuinely novel problems from first principles, the exact same way a human scientist or a detective does. It would be able to learn a totally new skill completely from scratch and then transfer that knowledge seamlessly between entirely unrelated domains. If achieved, AGI wouldn't just be, a faster version of the AI we use today. It would be a total qualitative transformation. Just imagine a system that actively directs its own learning, actually realizes what it doesn't know, formulates its own original research questions, and just operates autonomously in the real world over extended periods of time. Understanding this distinction really matters, because we're not just talking about an engineering milestone here. It's a shift that would fundamentally reshape human agency, economics, power, and honestly, the entire nature of professional work itself. Let's jump into section 3, capabilities versus limitations, a calibrated realism. We absolutely must celebrate the monumental achievements of AI right now. I mean, these systems are matching specialist physicians in certain cancer detection tasks. And AI actually contributed to the 2024 Nobel Prize in Chemistry for predicting protein structures. That is a massively complex problem that defeated human scientists for half a century. But, and this is a big but, we have to simultaneously recognize the structural flaws. While AI can solve short software tasks in the blink of an eye, it fails spectacularly at multi-step logic problems that require holding a chain of genuine reasoning. And yes, while it writes beautifully, it frequently produces very fluent, very plausible-sounding falsehoods. So for those of you relying on these tools in the legal, medical, or financial professions, These limitations are not just minor edge cases. They aren't just temporary bugs that'll get patched next week. They are structural characteristics of the technology itself. Hallucination is probably your biggest daily risk. A language model doesn't go retrieve facts from a verified database. It just predicts the next statistically likely word. So if the answer isn't in its training data, it's going to confidently guess rather than just admitting it doesn't know. It also really struggles with extended tasks. Human experts still heavily outperform AI when a project requires sustained autonomous effort over many days. And we literally cannot ignore the pure resource intensity required to build these things. To put this in perspective, the carbon emissions required to train just one large frontier AI model equate to several hundred transatlantic flights. When you add in the massive energy required to actually operate these models at scale from millions of queries a day, well, the logistical footprint becomes a major operational factor that organizations simply have to account for. Which brings us to Section 4, Why AI Cannot Think. The seductiveness of fluency. It is so incredibly easy to fall into what I call the fluency trap. When an AI produces this grammatically flawless, highly relevant text, our human intuition immediately jumps to the conclusion that there must be a mind behind it, actually understanding what's being said. But I want you to think of philosopher John Searle's famous Chinese room thought experiment from the 1980s. Imagine someone locked in a room who doesn't speak a word of Chinese, but they have this massive rule book telling them exactly which Chinese characters to output when they receive certain characters as input. To anyone standing outside the room, it looks like a completely fluent conversation, but inside, there is zero comprehension. None. The AI is the person in that room. It is just following a massive statistical rulebook, absolutely not comprehending the words it's creating. Let's really look at the stark difference in cognitive processes here. A language model is, at its very core, a prediction engine. That's it. It calculates the most statistically likely next word. It is purely pattern completion. Human comprehension, on the other hand, that is grounded in a physical, working model of the real world. When a human doctor makes a diagnosis, they aren't just applying statistics. They are integrating context, physical reality, the patient's history, and they have an acute awareness of the real-world consequences of being wrong. A human can say, I don't know, and actually mean it. The AI cannot. And because the AI is merely predicting rather than reasoning, we run straight into the structural problem of historical data reproduction. Look, a human expert can pause their work, take a step back, check their own logic, and consciously correct for an error or a bias in their data. An AI has absolutely no internal mechanism for reflective correction. It just mathematically reproduces whatever patterns and whatever flaws exist in its training data. It can't pause its processing and ask, wait, is this fair? Is this correct? It only produces what its statistical model calculates is likely. Finally, let's look at the human arbiter. You are the final defense. Ultimately, because these systems do not think, your role as the human expert is literally more vital now than ever before. AI predicts, you reason. AI pattern matches, you comprehend the context. AI reflects historical data, you reflect on the real-world consequences. Every single crucial AI output, whether we're talking about a legal draft, a medical summary, or a massive strategic plan, requires rigorous review by a human who actually understands the domain. The judgment required to know exactly when to trust the AI, when to verify it, and when to reject it entirely, well, that simply cannot be delegated to the machine. Look, these are incredibly powerful tools, and for sure, ignoring them means falling behind, but you have to use them with your eyes wide open to their true nature. So, I'm going to leave you with this provocative thought to consider today. In a world that is increasingly filled with persuasive, fluent, but entirely unthinking machines, how will you ensure your human judgment remains the final word? Thank you so much for joining me for this explainer, and remember, keep questioning the technology around you.